Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Tarmizi bin Abdul Razak. My register number is 11DK20F1041.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Khairuniza Ibrahim. 11DKA 20F1055 is my metric number.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nur Shauki bin Ahmad Fazil. My metric number is 11 DKA 20F1044.
Okay, for our objective, the lightweight roof trusses installation are to know the exact materials to be used in practical work. Number 2, to know the function of tools to be used in practical work. Number 3, to understand sequence of installation process for IBS roof trusses.
And now I continue the presentation about project roof installation, which learning outcome. For the learning outcome, student gain knowledge and able to apply, assemble suitable green material and IBS components with supervision, and then to demonstrate punctuality and responsibility in completing tasks of assembling green system and IBS. So the next is introduction to lightweight roof truss. Lightweight steel system offer a strong quality product, a fast and easy building process. Constructing with steel result in unmatched again strength is a structure ability to withstand wind loads, weathering, water impact, and interior deadlocks. The final quality of a steel structure is quickly recognizable. All corners are squares, floor are level, and walls are straight and pumped. Lightweight steel roof trusses are fabricated to exact measurements, avoiding the mold or mildew attack, dry road, humidity, termite damage, and eventual roof leak roof truss are prone to. The consistency of lightweight steel structure also allow finish to be standardized and installed more efficiently, including door frame, window frame, trim work, cabinet, countertop, plumbing, and electric work. This standardization and the lightweight nature of lightweight steel leads to cost efficiency in the form of bulk discounts and lower foundation costs. A lightweight steel building can also be designed and erect in a matter of months, years, so the return on your investment is realized faster, and common delays that erode developer profit and are minimized. So the benefits of lightweight steel system do not stop at the investing developer. The introduction of new technology, advanced building construction method into a developing country result in the creation of new jobs and new trades for local that offer higher pay. So the local workers can easily be trained to learn how to fabricate, panelize, and erect lightweight steel structures, and engineers and architects can be trained to design a building system using lightweight steel. So as a result, a workforce can be trained in much shorter period, becoming proficient at excellent work, producing a high quality product.
Okay, the next section is materials. The materials that we use when about to install the roof truss are C-channel, self-drilling screw, L-bracket, wall plug, and battens. Okay, the first one is batten is a small section of timber or steel which provides a means of supporting, positioning, or fixing roof cladding and ceiling sheets. For wall plug, also known as an anchor or roll plug, is a fiber or plastic insert used to enable the attachment of a screw in material that is porous or brittle or that would otherwise not support the weight of the object attached with the screw. Number 3, L bracket, to connect the horses to the wall plate. There are many tools that we use to install the roof truss. They are hammer, plier, adjustable spanner, hand drill, hand snips, grinder, wheel cutter, measuring tape, L square, spirit level, and marker pen. Okay, the first one is hammer. Hammer is a simple tool designed to manually drive nails, brads, and other fasteners into softer materials such as wood or drywall. Number 2, pliers. Pliers are a hand tool used to hold objects. Number 3, adjustable spanner. Its function is the same as any regular spanner, to grip fasteners, such as nuts and bolts. However, only adjustable spanners can grip fasteners of all sizes. Number 4, hand snips. Snips, also known as shears, are hand tools used to cut sheet metal and other tough webs. The next one is hand drill. Hand drills are used to drill holes or secure two objects together. They can also be used for drilling concrete, steel, and other construction materials depending on the bit used. Okay, the next one is spirit level. Spirit level, bubble level, or simply a level is an instrument designed to indicate whether a surface is horizontal or vertical. Number 2, hand grinder machine. They are basically used for cutting, grinding, polishing, sanding, and sharpening purpose. You can use them on metal, ceramic, concrete, and wooden materials. Number 3, wheel cutter. Cutting tool or cutter is typically a hardened metal tool that is used to cut, shape, and remove material from a workpiece by means of machining tools as well as abrasive tools by way of shear deformation. Okay, for marker pen, L square, and measuring tape are for marking section. Okay, the next one is sequence of fabrication. Okay, there are 7 sequence of fabrication. Number 1, check the actual size on site. To transfer the length size to the new C channel according to the same scale as the actual dimension and to avoid any errors on the new roof truss. Number 2, list each member and cut. Okay, list each member and cut, like how many for top, web, and bottom. This can simplify the work during later installation and save time by sorting by type. Number 3, labeling of each member, like top, web, and bottom, to avoid mistakes during installation and save time from wanting to find the types. Number 4, trim and notch C channel as its top, bottom, and horizontal. Trim and notch C channel by following the same as the actual dimension on site. Number 5, setting and fabricate the truss members. Number 6, depth the same truss and equivalence, so that there is no confusion when wanting to install it to a new roof truss. The last one is stack and store the truss at the appropriate place.
Okay, for the next is method of installation. After the fabrication process, we have 11 steps for method of installation. So the first is marking and fix L bracket on roof beam for tighten condition of the roof. So the second is hoist and sequence the truss of the roof beam as per drawing. Then stand the steel truss and fix the temporary bracing. Install hip lever and belly track if any, and then install the batten perimeter. So the next is install roof insulation for reduce head the head. And 7 is install roof batten for less wear of bender. If we use a batten roof, there is less risk for leaking. And then install lateral and diagonal bracing. So the 9 is tighten L bracket with handrail for the tighten by using a screw. And the 10 is install roof accessories like board and another example for the finisher. So the last is perform visual inspection. If anything wrong, just adjust to get a high quality.
So today I would like to present about our drawing plan of our project, which is roof project. So basically this is our drawing about roof truss project. So firstly we have sheet A, this sheet. So we have this view plan, which is showing the top of the roof view. Okay, so basically we have this dotted line, which is show the area of full roof area. So and then we have this T2 and T1, which is present as truss. And then we have C3 and C4 as the channel. The length for this side is 3910 millimeters, and for this side we have 3220 millimeters, which is we use millimeters in all our drawing to ratio as 1 meters go to 1000 millimeters. So in this our plan we use millimeters as the ratio here. So all the calculation that state here using millimeters. And then we have priest at the both side here. And then we can see that the length for between 1 to 2 is 3000 millimeters, and followed with 610 at the left and 300 millimeters at right. And it has same length with these particular sides, but with this present as the side which is weight plate at the bottom, which is we have this from T2 to the first weight plate, which is 600, and then we have T2 to T1 weight plate, which is 1150. Same goes to T1 and this truss. And then for the balance we have 400 millimeters. For this F side we have 2000 millimeters and continued with both sides, which is 610 millimeters, which total show 3220 millimeters. This blind line show that the particular things are being inside or under the other structure. Alright, now we go to A1 sheet, which is show the batten layout. We have two different type of batten layout here. So we have first we have T batten layout, and second we have N batten layout. For T batten layout, we use length of 3910 millimeters, while for the both side, while for the left side here we have 3220 millimeters. So basically each batten we gaps with 300 to 330 to 256 millimeters. So in between of two batten until the top. So basically the length of the batten is decreased until the top, and it will connected from this side to this left side, and then connected to the last part, which is here. Okay, now we go to the next sheet. We show this channel 4. So from this we can know that C4 showing us that is channel 4, and 2 showing its quantity, which is at 2, and then we have 1200 millimeters, which is the gaps between two channel, and then we have this 25 degree, which is show us the degree that used to slope the particular channel. So we have length of 1776 millimeters here, with when we calculate the triangle, we have an opposite of 751 millimeters in the inside, and the outside 834 millimeters. Alright, now we go to the next sheet, which show HR5, which is top chord. So we have two quantity of top chord, and we have 1200 millimeters space between two truss, and then we use 18.249 degree. Alright, then for the next sheet we have truss 1, which has two quantity, and they use 25.00 degree of slope, and they have gaps between two truss, which is 1200 millimeters. So we can see here 1776 the length for top chord. Okay, and we can see the truss is shaped as a king truss. Okay, you can see the shape of king truss because they use one point at the peak. So, and we can see here we have web 5, web 7, and then we have these P3 at the bottom. So we can see here the summary of all members that use here. We have truss 1, truss 2, then we have P3 here, and then the web members here. Alright, now we go to the next sheet, which is this, we look at the detail at the connection between chord to chord and web to chord and others. So we look at one of them for the example, such as detail C, this update joint connection detail. So basically we can look here, we have two top chord and connect with both web from bottom, and then we can see here they use 7 screw to combine them, okay, using a web. So we can see 1 2 3 4 5 6 7 screw used, and from web to chord they use 3 only screw to connect them and combine it to be a structure or a huge truss. So basically the amount of screw is really important, which is it give a good strength and a good structure to our roof truss. So basically the amount of screw play a huge role in the structure, which could give it the big amount of strength to our roof truss. So the place and amount of screw are really important to give a good structure to our roof truss and make it sure it's not gonna collapse. Next, we go to the next sheet which show us RHS, which is rectangular hollow structure. So basically they are made of hollow steel which has space inside. So they combine together with peak of 100 millimeters times 50 millimeters times 1.9 millimeters for all structure. So basically all of them use base of a plate that thick of 300 millimeters times 200 millimeters times 10 millimeters for all. And we can see here they use to create rectangular for total shape of the structure, and use of length 3,300 millimeters 3,000 millimeters for length, and width of 1,000 millimeters with height of 2,000 millimeters. Alright, then last but not least shade of this particular drawing, we have the general design criteria that used in our project. So basically there are several of criteria that we must follow, and it followed also by the other specific things we should determine and we have to use, because all of them we have to create a structure that according and approved by the truth according. So basically from this sheet we can conclude and that our project according to the term. Alright, now I continue to our last slide, which is our working table for our project. So basically we started our project at 30 November 2021 and we started with the fabrication progress for section A. So basically during on that date we already done all the 7 steps of the fabrication process. So basically we can conclude that we success to complete all the fabrication process in 1 day. And then for the next week we continue with the section B, which is installation process. So the date is 7 December 2021. So we, regarding to our table, you know that we can only do until the step of install roof pattern, which is 7 step of the installation progress, and then we continue for the next week with the next step, which is step 8 until the step 10 on 14 December 2021. Until then, we continue to proceed our process until we had to do a report and hand over on 28 December 2021, which is the date that our project is totally complete. So that's all from us. Thank you. In conclusion, I would like to say that sustainable construction lead us to use lightweight roof truss, which is give us opportunity to, in a way, to create a very good action on protecting our mother nature. I hope that youth can realize now and apply this to our next generation, as we are the protector to our mother nature, and hopefully our next generation can use and apply all of the sustainable construction in a way to create a very new world with peace and no harming, also benefiting to all of human beings and creatures. Thank you.